We know about sine and cosine, but what about all those other funny trig functions? So maybe we already know about sine and cosine. We saw tangent already too, but tangent could be defined in terms of sines and cosine as sine theta over cosine theta. Cosecant is just defined to be 1 over sine theta. Secant is 1 over cosine theta. And cotangent is 1 over tangent theta. What's so special about those 6 functions? I mean, why do we even have a function called cosecant if it's just 1 over sine theta? Why don't we always just write 1 over sine theta? For that matter, why even have a function called tangent if you can compute tangent in terms of sines and cosines? It doesn't seem like you need all these functions. To make matters worse, there's even other functions that practically no one knows about anymore. In addition to these, there's the Haversine function, which is just defined to be sine squared of the angle over 2. I mean, you really don't need Haversine once you've got sine. Considering that most of these functions can be defined in terms of other ones, the reason for studying, these 6 trig functions isn't really mathematical. You don't really need cosecant if you've got sine. The reason for emphasizing these 6 trig functions is cultural. These are the functions that people are likely to see when they open some technical manual, and knowing about these functions can sometimes give you the right intuition for how to attack a problem. Because sine and cosine are the legs of a right triangle with angle theta and hypotenuse at length 1, just by the Pythagorean theorem we get this, that sine squared plus cosine squared is equal to 1. Now if you believe this identity, you could divide this identity by cosine squared and you get sine squared over cosine squared plus cosine squared over cosine squared is 1 over cosine squared. Now because we've got all these other functions, I could rewrite sine squared over cosine squared as tangent squared. Cosine over cosine is 1. And 1 over cosine squared is secant squared. And this is maybe an example of how knowing about the other functions can be helpful. It's a little bit easier to internalize this identity. I mean, if you walk around and you happen to notice a secant squared, you can think, oh, I'm just going to replace it with tangent squared plus 1. Then, say, trying to internalize this middle identity. There's also a lovely geometric picture that kind of sells you on the idea that these 6 trig functions have some special role. For example, here's a unit circle, and I've drawn an angle of measure theta, and we know what some of the lengths in this picture are. This length across the bottom here is cosine theta, and this length here, the height of that right triangle, is sine theta. But it turns out that the other 4 trig functions are also encoding the lengths of other relevant lines in this diagram. For instance, this line here has length tangent theta, and this line between the point and the y-axis has length cotangent theta. And if you measure along the bottom here, the length from the origin to where this tangent line crosses, that has length secant theta. And if we measure over here from the origin to where that tangent line crosses the y-axis, that segment has length cosecant theta. So when you put all these functions down, we've got cosine and sine, but we've also got very visibly cotangent, tangent, secant, and cosecant. And the secant is measuring, something that's crossing the circle, and the tangent is really measuring the length of part of this tangent line. Now if we take this picture and wiggle theta, you can get an idea of how all the trig functions vary together. For instance, by looking at this picture with theta moving, you can get a sense of how these functions are moving together. For instance, tangent and secant are moving together, right? When tangent's really big, secant's really big. And conversely, when cotangent is really small, cosecant is small. It's close to 1. That gives you some idea as to why tangent is called tangent. Why is sine called sine? So sine comes from this Latin word sinus, like the thing in your nose. It's like an opening. And if you like that as a mnemonic device, you can remember that sine is measuring this side of the right triangle, because you can imagine that the right triangle sort of opens up in that side.